Hi everyone. Today I will show you how to use Excel programming to write your first Monte Carlo simulation program. So in this program I will try to calculate the value of pi. Pi is 3.14, which is used to measure the area of a circle. But here we will use the Monte Carlo simulation to calculate the value of pi. So our goal is to calculate the value of pi. So let's start here. So for Monte Carlo simulation we always require a random number, which is we can get in Excel using equal to RAND and then parenthesis. So if I just say enter, then it will give me a random number which is between 0 and 1. So I can double click on this cell again and then press enter, and again it will give me an entirely different number. So double click again, enter, double click again, enter, right? It's a random number. Now if I want a random number between -1 and 1, then what I have to do is just modify this equation a little. So instead of writing just RAND parenthesis, I will say 1 minus 2 into RAND. So now suppose I have a random number of 0.5, so it will multiply it by 2 and then subtract it from 1, so I will get 0. If I have random number of 0, then it will just multiply by 2, which will be 0, and then subtract from 1, it will be -1. It will be 1. So therefore you can go from -1 to 1 if I use this equation. So again I enter here, I get 0.63, double click, enter again, I get 0.79. So it's again right now it's not showing a negative number, but if I keep trying to see, now it's got a negative number of 0.77. I can also copy this random number again here. So now I have two random numbers, one in column B and one in column C. Now let's write 1 here and 2 here, so that we can get a series or counting of these random numbers here, and then copy these random numbers uh, down. So now we have a set of random numbers from 1 to 9, and let's call this column X, and then let's call this column Y. Now we can copy this number again until as much as we want. Let's do it until 1000. So right now I do it until 1000 here. Now we have 1000 number both in column X and column Y. So let's select both column X and Y and say insert, and then say scattered. Now we get a scattered plot which has this number plotted. Let's call this. So now this is a scattered plot of these numbers from -1 to 1 in x-axis and -1 to 1 in y-axis, and this is a rectangle with length of 2 and height of 2. Now here we have defined a rectangle. Now let's define a circle within this rectangle of radius 1. So we know that the equation of a circle is x square plus y square is equal to r square, but here we are defining a radius of 1, that's for x square plus y square is equal to 1. So now if we write if statement here, so I say is equal to if x square plus y square is let me put one bracket here, is less than 1, then write x, otherwise write 0. So now get this, and then again copy the same equation and say if x square plus y square is less than 1, then write y here. So now what I'm doing here is now copying x and y in these two columns if x square plus y square is less than 1, otherwise it will write 0. So I can copy this again now, and I can see that it copies the number, and then if I go until 1000, So now you can see that sometimes I have zeros and sometimes I have the numbers. So whenever the point is outside the circle, it gives a 0. Now if I plot this 2 series again, then instead of getting, I can delete this. So instead of getting a rectangle, now I'm getting a sphere, and the radius of the sphere is 1 and the center is 0 0, and it goes from -1 to 1. And this is how I have what I have done is selected the points which are within the circle, and if the points are not within the circle in this rectangle, then I just make them 0 and 0. So now I define a circle here. Let's put this graph here, and now let me again copy this equation and write it here, and say that if it's less than 1, then write 1 here, otherwise write 0. Okay, so I kept 0, and then again copy this equation and say write 1, and otherwise even write 1. So in this case it will always write 1, and in this case it will write 1 only when the point is inside the circle. Now again I copy these numbers and go down all the way to 1000 points, and then I see that sometime this column is 0 and sometime 1, but this column will always remain 1. So now if I sum all these numbers, it says sum and then goes down, and sum all these numbers. So I got 776, which is number of points which are within the circle. And then if I copy it again, so I get number of points which are on the rectangle. So obviously all the numbers are on the rectangle, so we will get 1000, and these are the numbers which are not in the rectangle, which are in the circle, but whichever is outside the circle is been removed. So now if I say what is this number divided by this number, so this will be equal to area of circle divided by area of rectangle, and that is equal to 780 divided by 1000. So now this is my area, but as we know that area of the rectangle is 4, so if I multiply this number by 4, I'll get the value of pi. Now you are wondering that value of pi is 3.14, so why it is 3.104? And this is because we have only 1000 points for calculating this pi. So if we increase the number of points, we will get much closer. So now let's double click on this pi and press enter. So I say the value of the pi has changed to 3.244, and this is because its value is again recalculated, and again because of the poor statistics my value fluctuates. But if I do this step again and again for thousands of times, then the mean will be 3.14. So another way to increase the statistics is just to go instead of 1000 points, we can go to 10,000 points. So suppose now I'm here and I just copy all these equations again, and then go down and go down and keep going down until suppose maybe let's go to 10,000 points. So now if I copy it very badly, no, it's going more than 12. Let's make it around 12,000. It doesn't matter. So we go up, and then in this sum, instead of putting 1000, let me put one more 0, and then same here. So I can see that now my value of pi is much closer. So if I click again and enter says 3.14, I can click again, press enter, 3.148, click again and enter 3.16. So now the fluctuation is much less, the standard deviation of the number is much less, and we are much closer to the mean value, which is 3.14. So if I, instead of using 10,000 points, if I use 100,000 points, then I will get much closer value of what it should be of the pi. So this is how we can calculate the pi. So we followed a simple step. We define a rectangle, then put a condition that whenever the point is inside the circle, choose that point. Then from that we get the area of the circle, and then from area of the circle we calculated the value of pi. I hope this tutorial will help. Thank you.